All right, I want to just rest here just a little bit and give people an opportunity to log in. A little bit of time to settle things in. All right, well, let's get this show on the road. Greetings, Houdini fans. It's Friday and it's 3 o'clock. So, welcome to another episode of Houdini Secrets Live. My name is Chris, and I'll be your host for the day. And as promised from a couple weeks ago, we are going to indulge ourselves into a series of episodes explaining all about Houdini dynamics. Now, Houdini dynamics is one of those elements inside of Houdini that is really, really big, but I myself stopped focusing on Houdini dynamics when I started working in the game industry, because the game industry, you can't play real-time dynamics inside of the game because Houdini is not in the game, right? And so I stopped learning about that. And that's about the time that Houdini deviated from POPs and then now is going into the dynamics environment and the dynamic network, right? And so I never really learned the modern way of doing dynamics. And so really this is as much of a learning experience for me as it is for you. I've always been able to use it here and there, but I've never really did a deep dive enough for me to actually explain and teach these concepts. So this is my opportunity to share with you what I'm learning. And actually I'm having a butt busting time because it's been pretty cool. Today, we are going to be focusing on just Houdini particles. That is a really simple and basic and kind of an entry-level introduction into Houdini dynamic networks. And it's actually very simple. And actually, the more and more I learn about these Houdini dynamics, the less mystifying it is, and the more I realize. And hopefully, I'll be able to impart that information onto you. Okay, so without further ado, let's get our conversation started with Houdini dynamics and Houdini particles. All right, I'm going to shift my view over to my demonstration window, and I'm going to shift it over into my demo mode. Okay, and I'm going to hide my Python. I don't think we're going to be using any Python today. All right, now we're going to keep this simple. And so we're just going to be focusing on the fundamentals. The strategy here is that once we keep things simple, then you should be able to use these tools for just about any situation that you might encounter if you understand the fundamentals. And I believe I learned about this when I studied Kendo, and in Japanese, the word for the fundamentals was, I think the term was kihon. Kihon. Yeah, something like that. But anyway, what that means is if you understand the fundamentals, then with a little time and meditation of your own, you could be able to mold these skills into anything that you want. So let's get things started. You start off with just a simple geometry. And we're not going to throw Roberto in there. Sorry, folks. We're just going to keep things even more simple. And I'm just going to call this particle fountain. Yeah, that's what we're going to do, folks. Just focus on a particle fountain. Not particularly too much, but yeah, it's good enough. Going to drop into there. And so this case, I'm just going to do is drop in a donut. So I'm going to drop in a torus object. And we have our torus object. It's a little bit big for what we want, so I'm just going to scale this down to about 0.1. So it's itty bitty. And make sure that the y-axis, its orientation is in the xy direction. Okay, good enough. Now, in order to make things brevity, I just wanted to emit from the half dome. So I'm going to list a, put in a delete SOP in here. And I'm just going to cut it in half. And so let me put on the bounding volume. And so I'm just going to move it down just a tad so that we just have half a donut. Okay. So it's 0.5 here. No, that's convenient. Okay, we have our half donut. Okay, that's all we really need for now. Something simple. And then let's not waste any further more time. Let's just drop in a Dopp network. Actually, in this case, drop in a PopNet. Now we could have dropped in just a regular Dynamics network. That would have been fine. But the PopNet has a few presets in it that are kind of set up for us. And I'm going to actually call this Particles. Yay. Okay, we're gonna drop into that. Notice that as soon as we turn it on, the whole donut gets replaced by a bunch of dots, a bunch of points. So if we hit return and go back to the start and hit play, we see that it eventually fills in and we see all the dots filling in there. Okay, so that way we know it works. Okay, that was easy enough. Well, let's go take a look inside of this particle network to actually see what's going on. All right, this is a very simple dynamics network, and that's all we really need to get things going. So what are the elements in here? Well, the first thing you need is this pop object. Now, this pop object stores the particles and the particle data. You don't really use it so much interactively within the context of the dynamics network. However, you do use it as a reference for when some other resource needs to tap into where the particles are, you would give them this object. Rather than calling it like the output, you would actually give them this pop object. We're going to play with that in just a little bit. And then also what you need is a pop source. This pop source is the interface for the initial particle attributes and the emitter behavior. And so things like where does the source come from, how many particles get birthed, how long do they last, what kind of attributes they have. Basically, the attributes have to get inherited from the outside coming in. So really, it's not really adding too many new attributes here other than velocity. Now, we could modify the particles and add attributes afterwards using all the good old-fashioned Houdini techniques that you all know and love. But really, that's all that's going on here. So you really don't change much here into the pop source. And then here is the pop solver. Now, the pop solver is the actual brains of the operation that does all the gobbledygook here. But it really does nothing more than configure the engine. It breaks it up into time scale and substeps and so forth in order to break things up into getting more. It's like, because this goes by frame by frame by frame basis, but if you wanted to go up into subframes, like in between every frame you wanted to go do 10 subframes, well, you'd set the things in here. And update is for the drag component and using all these other behaviors. There's collision behavior, sleeping, binding, distribution. I encourage everyone to play around with this, but today we're not going to really monkey around with the pop solver very much. We're just going to stick around and just stick with the basic facts. All right, so this one thing does elude me, and if any viewers out there wish to comment and tell me why, you can do this. But what we're going to do is when we hit play, everything kind of just stays right there. And why does it just stay right there? Well, it's because these particles are being birthed, but they're not going anywhere. And they're not going anywhere because there's no gravity associated, right? So what we're going to do is just drop in some gravity. So I'm going to drop in a gravity node. And the gravity force goes right in here. All right. And if we click into the gravity SOP, actually it's a Dopp. It's not even a pop anymore. It's gravity Dopp. You can change things like the amount of gravity. And since we're in meters, negative 9.8 meters is exactly what we want. So if we start this and then we play it, now notice that it's emitting particles every single frame. And you'll see little kind of pictures of the donut because remember, it's only advancing one frame, it's only emitting one frame after another. And so we're not really getting any kind of subsampling. And that's the reason why we would go into the engine and change the subsampling when we want more information. Now the gravity goes here, but as far as I know, that is the only force inside of the entire environment that goes right at this spot. Now, why does it do that? I'm not exactly sure, but we'll go into this maybe just a little bit later. If anyone knows the reason why gravity always goes here, please share me your insights. Okay, so we know gravity works. And so let's go ahead and start monkeying around with the actual particles themselves. Ideally, what we would like to do is we're going to create a particle fountain. But if we create a particle fountain that the particles don't got to get just sucked by gravity, then they got to shoot up. But we don't have an initial velocity because all we're doing is we go up a level and we just have the donut here. That's all we've got. We don't have any velocity being set here or anything. And we can change that by going into the pop source and where it says attributes, where it says initial velocity, set that from use inherited velocity to set initial velocity. Then the interface here kind of shows up and then we can kind of go ahead and adjust things. And so let's give it an initial velocity of 20. And then the variance, and that stands for the x, y, and z. So the variance of maybe 5 in x, 20 in y, so that it could be real, real short or real high, or 5 in z, should give us a good distribution. All right, I'm going to click play, and wow. Okay, I'm going to click this to see. Maybe, okay, hopefully you can see those particles a little bit better. And they're going all over the place, but they are going up, and they are getting spread out all over the place. Okay, so that is basically behaving, pretty much as we expected. So we've got some initial velocity going, and we've got some initial velocity going, and we've got some gravity taking into effect. Now, if we are going to add more forces to this environment, we would have to go and append them, and this is what this merge SOP is for, or this merge Dopp. This merge Dopp acts as a funnel point for all of the forces influencing the fires. And so for this, we're going to add some drag because this is crazy nuts. It's all over the place. Let's give it a little bit more shape. So I'm going to add a drag pop. So pop, drag. Oh, and if anybody's wondering, they pop, why do you keep on calling these pops? Okay, back in the old days, Houdini particles weren't called dynamic operators. It was actually called particle operators. So particle operators, POP, pops. Okay. And we're going to put the pop drag right into there, into the merge. All right, so with that, we're going to keep the air resistance, and we're going to put this at 1, and we're going to ignore the mass. And so let's see if this has an impact. Oh, okay, so this kind of like blows up, and it makes it look a little bit more controlled. Okay, this is behaving, a whole lot better than like what we expected. Okay, so this is styling. This is very good. All right, so we've got that going. So we've got the particles a little bit under control. So now let's focus on their lifestyle because honestly, these particles, they're lasting forever. We could get old waiting for these particles to get old. So I'm going to just in my pop source where it says birth. Now go over to where it says life expectancy. Change that to about 0.75. And then the variance, change it to about 0.4. So 0.75 means this is what each particle is expected to live is 0.74 seconds. And because I'm at 30 frames a second, what's 0.7 times 30? What's that point? That's about 28 frames, something like that. 27 frames, 28 frames. Yeah. But that's what it is. And the life variance means vary it by 0.4. So click on here. And then we see variance on the length of the life of the particles, and we see them terminating. Some of them actually get right back to the level of the donut ourselves, but then the rest of them keep on dying earlier. All right, cool. All right, we've got that working. Now, it would be cool if we could just add a collision plane now. Okay, we could add a collision plane. Now, there's a couple ways of doing that. Now, a lot of you probably are used to using the old technique of using it on the shelf. But I kind of hate using macros because then I really don't know what's going on. But if I wanted to, here I'm going to do, I will right click here and choose ground plane. Okay, and now I just got to plug ground. Oh, what I'm going to do is put this into a merge. And then I'm going to move my pop solver into the merge and the merge into the gravity. Okay, now we see that the particles are bouncing off the ground. Hopefully you can see this. If you can't, let me put on the particles and maybe you can see how they're bouncing off the floor. So they're basically doing what we expected, but we also see on all the other points over here, so it's a little bit distracting. Okay, so an alternative way of doing this would have been if we had gone onto the, if we delete, I'm going to go ahead and delete this. And so we would have been about just fine. But if I'm going to go up here, I'm going to go up a level. So where we're looking at everything here. If I go into look for where it says collisions, do I have collisions up here? Boom, boom, boom. Yes, we do. And there is ground plane. We could click ground plane, and you'll see that it goes ahead and creates one for us, and it finds our Dopp network, and it goes and puts the ground plane right into there. And it's a little bit more robust than what I did because it gave you the opportunity to merge more than one collision plane in here, and it put it all into a static solver. Now, I don't really know too much about the static solver. I'm going to do more of a deep dive into rigid body dynamics next week, and so I think I'll have a lot more answers for you then concerning the static solver. But as you can see, we're dealing with the exact same situation as what we were dealing with before. All right. All right, we've got that set up, so let's keep on rolling. Now, let's talk about this Dopp order. When working with Dopps or dynamic networks, it's not really so much of a flow map. There's not, I mean, there is a little bit of flow going on here, but it's really just an organizational data for where the particle system actually looks at things and finds out which order and to apply things. And it goes from bottom to top and then left to right. So what we're doing here is it first goes into, oh, did this actually work? Okay, so it's working. So it's giving a ground plane for this to work. And actually, I thought that I would have had to happen, put the ground plane in there, but it put it before gravity. So I'm learning on this on my own. But the first thing it does, it goes ahead and grabs the ground plane, and then it puts gravity on it. The gravity doesn't affect the ground plane, so that it's fine, and it just flows up on top to this pop solver. Then it goes to the pop objects. It says, okay, cool, and then it comes back up into this merge and then goes into the pop source. This is where all the particles are being born. And then it applies and births all the particles. And then once the particles are being born, then it combines them with the pop drag, which is a force being put on side of these particles. Now we could have just put this right in here, but I kind of am a bigger fan of having it a little bit separate in order to de-emphasize that we're dealing with groups of operators and not necessarily a flow of operators. Okay, now, oh, since we're at it here, let's just go ahead and add a little bit of color. And so color in pops here is created with a pop color node. So I'm going to right click on here and throw in a pop color. And that once again goes dropped into the. Notice that most of these pop operators don't require an input because the input redefines the force area. And for this, we just want to manipulate everything. Now, in this situation, we're going to, well, I don't want purple or whatever this periwinkle color is. It's kind of ugly. Let's just go and put it on random. And then we're talking fireworks, baby. Okay, there's our massive multicolored particle fireworks level. Let's change my background to be a dark background. Maybe we can actually see things a little bit better. Yeah, it doesn't see much better. Well, a little bit better. Okay, now let's go ahead with our exploration of these pop forces that can go. We already put drag on. We are familiar with that. But what if we wanted to actually add some wind? So I'm going to go ahead and right click on here and say pop wind. Oops, I don't want to pop wrangle. I want to pop wind. Okay, I'm going to drop that pop wind in there. Now, the pop wind basically behaves like any other kind of force node that you've worked with. If you've never worked with a force node, then you've probably never worked with fractals, because this is basically a fractal generator that applies a regular fractal force. And so what I want it to go is kind of like in the y direction and into the negative z direction. So when we turn the angle around here, come on. Okay, come on. Go back to the beginning. There we go. So I want there to be a general flow of the wind in this regard. All right, so I'm going to change my air resistance. We've got that on here. I'm going to keep my wind velocity at 10 and minus 10. Okay, now let's play it. Okay, and now that causes it to blow off to the wind. And notice that the wind is a constant force. It is not an intermittent force. It is just on. And so this is a little bit much. So I'm going to toss in some air resistance. I'm going to put this to be about 0.1. Okay, and so now we can see that it behaves a little bit more as expected, and it looks like our wind is, or our fountain is being affected by a strong wind. I'm going to put this in at real time. Thank you. All right, now let's increase the amplitude of the wind, because right now we knocked down the air resistance, well, to be almost nothing. So let's put the amplitude up and move that to be about 3. And let's go ahead and reset it. Okay, so what that's doing is it's pushing things forward just a little bit more, not a whole lot, but a little bit more, enough to be just a little bit bigger. Okay, but this is fine, but let's go and put a little bit of swirl in it, because it to be, a little bit more chaotic. I like chaos. So where it says swirl size here, let's change that to be about 1, and the swirl scale, let's change that to be about 15, going in all axes. Okay. So we don't see much swirl going on here. So let me go ahead and remove the air, remove some of this air resistance. So instead of 0.1, let's go 0.5. Okay, so you can see it's starting to like go a little bit ape nuts all over it. It makes it look a lot more interesting, but the wind still is a little bit strong. So I'm going to knock that down to maybe 2.5. See what we got here. And regret we got to wait for it to finish again. Okay, so I'm going to limit. I want to go faster iteration. So what I'm going to do is I'm just going to move my time frame over to 100, and that's going to make things flow a lot smoother, I think. And so we now see that the particles are moving around a little chaos. Maybe if I added more particles, it would actually help. So if I go to the pop source and say with the constant activation around 5,000, well, let's make it 10,000. All right, click on there. And do we see a little bit more of the chaos? Yeah, it's a little bit more chaotic. Let's go back into my pop wind. I still think the air resistance is a little bit high. Maybe make it 1.5. Okay, how about add more amplitude? 10. Does that, yeah, it goes, okay, so it's going a lot more randomly now. Okay, cool. And now for the roughness, so we're going to leave everything as it is. Now, if you don't know anything about fractals, don't start playing around with this stuff, but ultimately this is basically a Perlin noise generator, and you're putting the Perlin noise onto the particles. So it's not a whole lot more difficult. All right. Now, the only thing else that I would want to change here is maybe, oh, let's have it sporadic. Like maybe this fountain can be found in Vegas, and it only happens every few seconds. So I'm going to go back up into the pop source here, and I'm going to change my emission because right now I've got a constant activation rate. But what if I actually wanted like an impulse rate? You know, to actually be a little bit more staccato. So I'm going to put my constant activation. I'm going to turn that to 0. And you'll notice we shouldn't get anything. But my impulse activation is set to 1, so we have to tell it how many we want. You know, if we put, 1,000 here, we're going to see it still behave like a constant particle, and it really is coming out bukus. That's a lot of stuff. Okay, beautiful. But how do we get the staccato? Okay, what we're going to do is we're going to put a function inside of our impulse activation in order to make it behave a little bit more curiously. And what I'm going to employ what I always employ in this situation because I love the modulus operator. So what I'm going to do is I'm going to type if, and the if function is a function that takes an expression, and then based on the contents of that expression, it does either a or it does B. And so let's take a look. I want the FF or $FF or the frame. If the frame modulus, oh, let's go 30. Well, let's go 20 because then it could be nice. Well, let's see, 25. Yeah, let's go 25. Okay, if the modulus of the frame rate, 25, equals 0, so that means only happen once every 25 clicks. Oh, that's right, we have to go equals 0. Then turn it on, which is a 1. Otherwise, turn it off, which is a 0. All right, click that. And then we're going to go around again. Okay, that's kind of like weak. Okay, so the simulation ends and it's doing it. So let's happen if we do this with 30. What happens if we go maybe 15? Yeah, that looks a lot better. Okay, so it's blowing particles all over the place. Okay, I'm going to go ahead and save this just so I don't lose anything. So save as is my job, and I'm going to contact this as demo fountain. Okay, we have the demo fountain up and going. All right, now let's go ahead and, so these are the basics. So really, there's not a whole lot to pops. If we hit tab here, and if we just type in pops or just go right to, this is all the pop stuff that we have. And so there's not a whole lot that we can do that we've got on here. Now there's stuff here for the pop fireworks, which is a little bit more, and the pop fluid is a little bit more, but haven't had a chance to really play around with these a lot, but really they're just kind of standard run-of-the-mill operations that you could apply onto particles. Anything you could do with a particle, you could probably do with one of these pops here. And we could put some drag on it. You could put some proximity. You could give it a little bit of spin. And I'm not sure what awaken means. I don't know if it's going to be like Cthulhu or something. And pop advec by filaments. That sounds mathematically demanding. We can create groups, we can create grains, and possibly we'll have a chance to play with these in the weeks to come. But really, this is all these are all the options that we have to play with, and because these are what are affecting particles. And that's really all there is, folks. There's not a whole lot to these particles. But anyway, suppose we go up to the level. And here's our operation, and we're looking at this, and I don't want to see the ground floor. And so if I click onto particles, we'll see that what we can see here says object show star. If we get rid of that, everything kind of disappears. It just freezes. What happens if I turn this off? Okay, remember how I said that there's one node in here that acts as the anchor for everything and stores all of our particles and our particle data? Well, this is this pop object. So I'm going to go and enter that title up in here. So I'm going to go request the pop object. All right, now pop object. All right, if I go ahead and reset, okay, so we see the pop object, but I was hoping that it would disappear. But okay, what we have here is just the pop object, so we're doing good. So I'm going to go ahead and save this yet one more time. Hit Control S. Okay, now I'm a real-time artist. I work in real time now. So I no longer refrain myself to the offline. And creating something, now creating particles in Houdini is fun, but knowing that I can't take them out of Houdini, I got to put them into the engine. And so the good folks at Side Effects Labs have created an interface for that. And we're going to do that using a ROP operator. Oh, actually, I'm not going to use a ROP operator. I'm going to use a regular operator, and I'm going to use a new labs operator. If you don't know what I'm talking about when I say Side Effects Labs, click over onto the plus, and where it says shelves, go over to where it says Side Effects Labs. Oh, there, make sure that that's turned on. Now, when you look at the Side Effects Labs shelf, make sure to hit the tool update to get the most recent version. Ah, yeah, there it is. And it's going to ask you, okay, it's going to ask me if I want to update. I don't want to update because I just updated right before this presentation, so I don't need to. So I'm going to go ahead and close that. And so what I'm going to do is drop that off of here, and I'm going to drop in a, oh, let's see. I want a Houdini Niagara ROP. So I'm going to go Niagara. All right, so I've got the Niagara ROP here, and things are pretty rudimentary. And I'm just going to go between 1 and, oh, I'm going to delete this channel and put it to 1 and 100. I only want 100 frames. That's about all we want. No, I don't want 300,000 frames. That's too much. I'm going to go get cigars tonight, so if I waited for that, it would never finish. All right, and now for my output path, notice that it outputs the data as HBJSON, JSON. So I guess that means for Houdini binary JSON. Now I don't want to do as a Houdini binary. I want to go and actually look at this stuff as if it was text. So I'm going to go ahead and change this and change the job. And I'm going to go send it to export. And I'm going to go into demo fountains, a new folder, demo fountain. Click accept. And then inside of my file, I'm going to call this demo fountain dot HJSON. Now, I don't want it to be binary because I actually want to take a look at it. So I click accept. Now, I'm going to leave everything as is because it's asking us which position to keep. And at this point, the only two attributes I'm going to have is position and velocity. So I'm going to go ahead and hit save again. Always save before you do any kind of exporting. I'm going to go ahead and click render. Okay, is it doing anything? I don't think so. I'll click render again. I don't know. Let's go open up a file browser and see if we have anything. So I'm going to go into my Houdini Dynamics folder and go into export and my demo fountain. And there it is. There's my file, and it's 1 kilobyte. Okay, something didn't happen correctly. Aha. Que lastima. Oy vey. Okay. I made a huge mistake here, gang. And okay, rumba. I just realized this, and I haven't gotten full feedback from the Houdini folks yet, but there seems to be a wee bit of a problem with the newest version of Houdini 18.5, and because it's by default has Python 3 automatically put into it, the Python 3 causes the Niagara output thing to mess up. It goofs up. Oh my. So what that means is that this network would otherwise need to be built inside of an other version of Houdini that is not running Python 3. It's running Python 2. Hopefully, we are in March 26th, 2021. Hopefully, by the time that you watch this, well, side effects would have fixed things up and everything has been migrated to Python 3 adequately. But for me, I have to monkey around here. So what I'm going to do is I'm going to save this, and then I'm going to close up my, I'm going to go ahead and load up another version of Houdini that I already have this scene basically created. It's not going to be exactly the same, but you're going to get the right idea. Okay, waiting for Houdini to come up again. So this is 18.5, but it is a different version with old Python 2.7 in it. And this one actually works. But I knew something was wrong. I said, like, wait a second, should I use the Python 3 or Python 2.7? I said, no, I like Python 3. You know, I'm trying to teach myself how to use Python 3 rather than Python 2.7. The industry has been Python 2.7 for the last almost 20 years. And going to Python 3 is a little bit of an adjustment. So we're almost there. And let's see, do I have any projects? Yes, we do. And we gotta click open. And then job, okay. And then simple fountain, okay, cool. I click accept, discard and open. Okay, so let's get this bugger in here. All right, let's go back into my demo mode. Oh, that's not what I wanted. Let's go for this one. Okay. If you go into the geo, all right, here is our network. Pretty much exactly the same. If we go ahead and play this, whoa. Okay, there we go. We're getting lots of flow out of this, and we're getting lots of kind of spitting out and so forth. So a nice simple flow here. Now notice here that we aren't outputting the point color information because we're not really using that yet. And so this information is going to be ignored. But if we go and look at our Niagara, now this actually is a SOP. It is exporting color. We have CD here that's being exported. So this is being exported also. It's not being exported. We're not going to use it, but I'm going to go ahead and click on, it goes from 0 to 240. I'm going to go ahead and render this. And yes, now it's taking a little while to go. Okay, it takes a little while to think and so forth. About, oh, I don't know, it's been working on 12 seconds. Okay, not bad. So let's take a look at what this HBJSON file actually looks like. So I'm going to go run some Sublime. And what did I call that? I called this test demo HJSON. Okay, good. Let's open up that. And look at this. It's big. It's really big. It's freaking big. It's so big here that I don't want to wait around for this to finish loading. It's so big. I can just know that I've got thousands of particles of data in here, and they are done for every single frame. And as they are born, more and more particles, and so it just gets slower and slower and slower. Now, I don't want to open that. Let's just kill that. We don't need that. Okay, so opening up this scene, not such a good idea. Oh well, live and learn. So let's go into UE4 and see what we can do with all this. So here we are. I've got a little level here created ahead of this. So let's bring in that data. So I'm going to right click in here and I'm going to import into the dynamics. And so, no, let's not, for this, wrong folder here. Check our edu. Okay, we got the Houdini secrets, we got Houdini dynamics, and we're going to go to export. Then we're going to call this demo fountain. And here's my demo fountain, HJSON. Click open. Failed to import. Well, that's not fun. Okay, let's just see why it didn't import. It should have import, but it didn't like it. Why is that? So let's check to see if we have our Houdini environment actually loaded. So let's go in here, go to edit, edit preferences, plugins. Yes. Okay, in order to get Houdini talking to UE4, we ultimately have to load in this JSON file. This JSON file has all the information of where all the stuff goes. So if we go ahead and slip on FX, cascade to Niagara converter. No, 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 no. Okay, lo and behold, I am missing. This is interesting. Okay, well, it's gone. Well, well, it wasn't expecting to be gone. This is surprising. Okay, well, let's go and find it and go and get it and put it in and install it. Okay, so it's not here. Joy, joy, joy. All right, so let's go ahead and we have to go to this website. And let me see if I can go to this folder and let me see if I can pull up a web browser here. Click on there. So here it is, GitHub/side effects/Houdini Niagara/release tag 426. Okay, that's what we want. Okay, so there it is, and we want this Houdini Niagara zip file. And I don't want the source code because I don't want to deal with any kind of compiling, monkeying around. I just want to get my converter that it should be good to go. So I'm just going to go ahead and drop that and zip this. Okay, now what we got to do here is we're going to get these content and then we're going to expand the contents to our projects plugins folder. So I'm going to go ahead and open this. So we go Houdini Niagara. So let's extract this to our projects plugin folder. So here we go to Tickar edu and Houdini secrets. And here's my UE4 project. No, that's not right. Houdini secrets. No, not there. Houdini dynamics. There's our UE4 scene. Houdini dynamics. And then here's our plugins folder. And then here's our Houdini diagram. I don't know why I didn't see it. But let's just say we select this. And then we want it to go to this folder and click OK. And then it says we want to overwrite the following. Yes to all. Okay, cannot create. What is going on with this? Archive? Why can't we access this? Oh, it's being used by another process. Interesting, interesting. Okay, so something is going on here that isn't quite copacetic. Okay, so I wonder if I have more than one version of UE4 up and going. So what I'm going to do is make sure that this Houdini is saved and then shut down. So this has already been saved, so I'm going to go ahead and close this. Interesting. So not only are we getting an introduction to the mishaps of using Niagara and Houdini, but we're also getting a little bit of a lesson of a forensic tech artwork. Yay! All right, so let's go ahead and I'm going to kill my UE4 scene. And let's go ahead and see if we can resurrect it somehow. And if all is good, then I should be able to load up the folder and my prior demo should already be hooked up. All right, so we're almost there. Let's get the file here. Okay, Houdini Dynamics. Okay. And we know that the folder is working. Because look at that. There we got particles there. Guess what, folks? These particles are driven by Houdini. Okay, so now if I go ahead and import the game and demo the fountain. Oh, this is 1 kilobyte. Yeah, that's why it didn't work. Because it's only 1 kilobyte. It's not correct. All right, so let's go back to the export. And if we go into this pulse fountain, and here it is, this test demo. This is the one that I created just the other day. This is what I just created now. If I click on open that, and it's importing, and it's loaded in. Okay, let's go back to this. Okay, so if we had successfully imported it correctly, let's take a look at the plugin. Now, what should have happened is we click effects, and oh, it isn't on there. I didn't find it. Okay, so where is it? Is it miscellaneous? I can't remember where it is. So if I just type in all and do a search for Niagara, there it is, Houdini Niagara. Okay, there it is. Import to Houdini, make sure it's enabled. If it's not enabled, you're going to have to turn it on because you're not going to be able to read in the files otherwise. But we just read them in, and so everything should be copacetic. Now, if we go ahead and look at it, this is what we're going to get. This is not actually a texture map. This is just a whole bunch of information that the good folks at Side Effects Lab kind of created as a plugin in order to store and handle all of this information. Cool for cats. And the number of samples, we have 331 particles. Maybe that's why it took forever to load into that. The number of attributes, we have 11 attributes. The number of points, 4,000 points. And the number of frames, 240. Wow. Okay. First frame is 1. The last frame is 240. Maximum sample time 0. Minimum sample time 0, 9.95. Okay. The attribute array, let's see, take a look at the attributes. What we have here is we have the ID. We've got the particle X, Y, and Z information, the red, green, and blue information. We've got the velocity for X, Y, and Z, and then we've got the time information. Interesting. All right, good. Well, we know that we're good to go. Okay, so let's go. I want to go to my Houdini demo level. Okay, don't save. I'm worried about that. Okay, so this should be fine. All right, so what we're going to do is we got to create a brand new Niagara effect. So I'm going to go ahead and right click into here and go to where it says FX Niagara system. And for this, I'm just going to go ahead and create an empty system. I'm going to click empty, click finish, and then I'm going to call this NS, not NAS, NS, and I'm going to call this Houdini Niagara demo. All right, there we go. Very simple. This is what we get when we add a blank thing. So what we want to do here is we want to add an emitter. And once again, the good old folks at Side Effects have come to us and they've created a little plugin for us that will drop right in. So I'm going to press this track to create a brand new emitter. So click track emitter, and then there's one here called there's a Houdini Particles, Houdini Interpolate, Houdini Niagara Basics. That's what we want, Houdini Niagara Basic. Go ahead and add that onto there. Now that added the whole new emitter, and look at that, we've got a default particle system that's already enclosed there, and look at that, they're thinking about donuts too. They must be hungry. All right, now there is what you have to do is there's inside of the emitter spawn, there is an init Houdini point cache information, but there's not a whole lot. So this is just an initialization state that gets things going. What you have to really update is where there's an emitter update. You have to emit the articles from the point cache, and then you have to list what the point cache is, and then you have to do that in the particle spawn and the sample or in the particle update. And so you have to do the same thing ultimately 3 times. So there's a more elegant way of doing that, and is by using the system settings and creating a user parameter that defines what we want for this. So I'm going to click on user parameter, and then for this user parameter, where the system says it, and so I'm going to go and add, do we create one more? Loop age, system emitter attributes, okay, system properties. Okay. All right, so let's see. We get the system settings. We hit the plus, and I don't see how it added one. Particle attributes. I don't see anything. Now we could add one here, but the system settings. Let's click one here. Ah, and now I guess I didn't press it properly. So what we have to do is look for a Houdini point cache information. So Houdini point cache information. That's what we want. All right, cool. Now we've got the Houdini point cache information. Now we're just going to change the name here. And so I'm going to right click this and choose a rename. We're going to call this HSL demo. All right, so we've got that. And now let's go ahead and select the point information that we want to. And so here is our Houdini point cache information. Interp world test demo. Okay, that's what we want, is test demo that we just pulled in here. And so nothing changes here because what we have to do is update all of this gobbledygook here. And so we've got that saved. So I'm going to go ahead and save this just for giggles. Now we're going to go to the update states inside of my emitter. And then I'm going to put in, instead of using this local information, I'm going to put in my system settings. So it kind of like automates things. If I ever wanted to go ahead and change things, then all I'd have to do is change my system settings. So I'm going to click here, and I'm going to go my HSL demo. Okay, that's got that. That's one. Click down here, HSL demo, and then click here for HSL demo. Okay, it's got to compile, and there it is. Okay, now you can see it's doing its thing. Well, I don't know if you can see this, but I can definitely see this, and it's floating right at us. Okay, so I'm going to go ahead and save, and then drop in my Niagara system, and there it is. Okay, now I didn't instance anything to the points here, and now I have to go ahead and, if I really wanted to play with this, I would add random colors and shaders and other things, random colors and maybe some different shapes to my Houdini particles, but that would be more of a lesson into more UE4 dynamics, and I really don't want to focus on the UE4 dynamics because this is really all about Houdini. But what we've been successful in doing is creating a simple particle system in Houdini, and then getting that and moving it all the way into UE4. And now we have a way of transferring a Houdini particle system into UE4, and then anything that we can simulate in Houdini can now be visualized inside UE4. Now that is cool because we have a one-to-one link between the two packages now, and they are no longer isolated. All right, that's good news. Okay, let's see. That is about all that I wanted to cover for today. And let's get this up here and going. I knew I forgot something. I tell you, if it isn't one thing, it's another. Let me go ahead and change this just so it looks a whole lot better. Okay, so you're going to have to look at my silly old mug. for just a wee bit longer. All right. And we're going to go ahead and move this here down a little bit more. All right. All right, we're almost there, folks. All right, great. So that's all I wanted to cover for today. So join us next week, and then next week what we're going to do is we're going to go into studying more of rigid body dynamics, because even though the dynamic system is really powerful, it can be a bit overwhelming. So we're going to start small and then build our way up, and I already know that we're going to go into a lot of interesting things next week, so be prepared. We're going to go really fast and dive into Houdini rigid body dynamics. So that's what's going to be next week on the 3-5, same bat time, same bat channel. All right. Now, if you're interested in tech art stuff, like other than this kind of tech art stuff that we had to resolve today, what you can do is check us out on Tech Art Talk Live. And that's also on 3-5, but this is going to be at 12. That's right. Ooh, 12 o'clock. And what we're going to be talking about is Python serialization. That is the fifth element in a 6-part series where we're introducing everything you need to know as a tech artist about Python. And if you're a Houdini artist, go check out that Python series as well, because it will help you with your Houdini as well. Now, if you like what you're just talking about, go ahead and hit the subscribe button to this channel and join into the conversation, join into the fray, subscribe, check us out, TechArt EDU on YouTube. Check out Chris Rhoda on Facebook and LinkedIn, and TechArt EDU is also on Facebook and LinkedIn. And if you really want to help me, go to the techartedu.com and go to the little sign up button where you opt in and click here in order to put your name. When you click onto that, I'm going to take your email address, and then I'm going to keep you updated on when there's any kind of changes within TechArt EDU. We're making big progresses with the real-time visual effects book, and so this is almost getting done. I just lost another one of my illustration artists. She got a job. I lost that. So if anyone out there wants to create some simulation illustrations for my book, contact me and then we'll talk. But sign me up there. You get all the information of what's going on with TechArt EDU, and we'll get going from there. All right. Thank you very much for joining me today. Thank you for putting up with all the shenanigans that goes on here every time that we put on TechArt EDU. You never know what's going to happen. And have a great week, and we'll see you next Friday. Arrivederci. Okay. It's time to stop this.